Section 3.3b. In the last section, we worked with expanding logarithmic expressions. Now we're going to use the same properties to condense them into single logarithmic expressions. So when we begin doing that, we know that when we have a number out in front of a logarithm, such as 1/2 and 3 right here, that those can be moved back to the exponent on the argument. So the first thing we can do here is rewrite this as log x to the 1/2 power minus log x plus 1 to the 3rd power. We know that raising something to the 1/2 power is the same as taking the square root of it. So let's clean that up a little bit. Minus log x plus 1 cubed. And now finally we have a subtraction of logarithms. We know that subtraction of individual logarithms came from a single logarithm in which the arguments were divided. So we end up with log of root x over x plus 1 cubed. There's our single logarithmic expression. Letter B. 2 natural log of x plus 2 minus natural log of x. Once again, the number out front of the logarithm, we know we can move back to the exponent on the argument. So we have natural log of x plus 2 squared minus natural log x. And again, we have a subtraction of individual logarithms. If I want to combine that into one logarithm, subtraction becomes a division of the arguments. So x plus 2 squared over x. Okay, letter C. A couple of different ways that this can be handled. I'm going to start by distributing the 1/3 through. When you're working with logarithms, remember you cannot split up parts of logarithms. In other words, log base 2 of x is all one expression. I can't divide by log 2 or divide by x or anything like that. That stays together as one thing. This right here has to stay together as one thing. So a logarithmic expression is made up of the logarithm, the base, and the argument, and those are all attached together. You cannot break them up. So now I'm going to distribute the 1/3 through. So I have 1/3 log base 2 of x plus 1/3 log base 2 of x minus 4. Move that 1/3 to each of the exponents. So I have log base 2 of x to the 1/3 plus log base 2 x minus 4 to the 1/3. We have a multiplication here. If I want to combine this into a single logarithm, this addition of the individual logs becomes a multiplication of the two arguments. And from here, I can simplify since they're both raised to the 1/3 power. Log base 2 of raising something to the 1/3 power is the same as taking the cube root of it, x times x minus 4. There's our single log expression that can be formed from this addition of logs. Okay, last example here, simplifying without a calculator. Once again, you have to be able to think of logarithms in terms of what they are. They are exponents, and you have to be able to simplify without the aid of a calculator. You will have to do this on both the quiz and the test as well. In this case, log base 6 of the cube root of 6. It's the same thing, and remember there's several ways that this can be done. First way that I'm going to do it both ways here. Log base 6 of 6 to the 1/3 power. And now we can use our properties of logarithms. We know that if the base on the logarithm is the same as the base on the argument, cancels, and we're left with whatever the exponent is, in this case, 1/3. You could have also taken this and set it equal to x and changed to an exponential. Base to the exponent equals the argument, 6 to the x power equals the cube root of 6. And now when you have like bases equal, that means that their exponents are equal. Again, you can use either method, but you need to show what method you are using. It will not be sufficient just to write an answer down. Letter B, log base 5 of 1 over 125. Well, if I'm going to simplify this, I need to write it in base 5. 125 is 5 cubed. If I take that 5 cubed now and I move it up to the numerator, remember that just changes the sign on the exponent. Let me write this correctly. And now we have the same property we just had over here. Base on our logarithm is the same as in the argument, and we're left with whatever the exponent is on that argument. Letter C, log base 4 of 2 plus log base 4 of 32. A couple different ways that this can be done. The easiest way is let's combine this into one log expression. When we have an addition of individual logarithms, remember we can combine those together by multiplying the arguments. 2 times 32 is 64. 64 we know is 4 to the 3rd power. And now the base on our logarithm, again, is the same as the argument, and we're left with the exponent.